Kidoki. Now at number 3 of this CSEC Admats 2023 paper 2 with a solution. All right, number 3. Let's get through this as quickly as possible. So this one gives us the equation of a circle, and it is given in the general form. They want us to determine the coordinates of the center. And the method I prefer to use is to complete the square, but also I want the length of the radius. So I prefer to convert this into the standard form. The standard form basically is this. Standard form is this. Let's write it over here. It is x minus a squared plus y minus b squared equals the radius squared. So what it is that when it is in this form, if you have a circle, the AB is the center of the circle, and the R is the radius of the circle. All right, so we just need to take this and complete the square of the x values and complete the square of the y values, and basically write this expression, this equation in this form. So we can pick out the A, pick out the B, pick out the R. So let's go. So first thing I'm going to do is put the x values together. And I'm going to be completing the square. So I'm going to write x squared minus 8x, and then put the y values together, which is y squared minus 18y. And this 93, I'm going to put it back, or I could transpose it. But let's leave it here for now. Equals 0. I want to complete the square of these two values. Right? So since coefficient of this squared is already 1, I can just proceed and do x minus half of this is 4 square. Then I subtract the square of this 4, which is 16. So I've completed the square of this expression to get that. I need to complete the square of this one now. So I'm going to go y, then half of this is 18. And it's a minus, comes a 9. Don't forget the square. Then I subtract the square of this 9, which is 81. And then I'm putting back this plus 93 equals 0. Right? That's what we have so far. So I'm going to put these together now. And I'm going to get x minus 4 squared. And this is y minus 9 squared. Consolidate these numbers now. Let's get the calculator and do that quickly. Don't have time to waste. Don't have time to waste. So that becomes 93 minus 81 and also minus 16. So we're getting negative 4, and the negative 4 from these values will transpose to the right side. It will become a positive 4, but that positive 4 is the same as 2 squared. So I'm just going to write 2 squared. And therefore, the center is the point 4, 9, because this is my A, this is my B, and this is my R. The axiom for the radius, it is this R. So the length of the radius, it is R, which is 2 units. We say units because length, coordinate geometry is measured in units. Area is measured in units squared. Volume is measured in units cubed. So the length of the radius is 2 units. Mostly units. What is that? Next part says, find the equation of the normal to the circle at this point. So I'm going to assume that this point is on the circle. All right, I think I'm going to check it. So what are they talking about? So we would have the circle, just to make a sketch. And this is the center of the circle, 4, 9 here. And then this point, 2, 8. So if you have 4, 9, 2, 8 will be lower. like about here. That will be the point 2, 8. It doesn't really matter. So this is 2, 8. And this point is 4, 9. And this is our normal. So we're trying to find this normal from here through the center, that line. That's our normal. We're going to just call it n for now. So to find the equation of that normal, we need to know two things about it. We need to know the gradient and a point when we have 2 points that we can use. What we need to find first is the gradient of the normal. All right, the normal passes through the center. So because I'm finding that red normal, I'm going to do the calculation in red. All right, so the gradient of the normal between these 2 points, the difference in the y values, that's 9 minus 8. 9 minus 8 over the difference in the x values, which is 4 minus 2. 4 minus 2. Subtract the values the same way, the same direction. All right, so this becomes 1 over 2. This is 1, and this is 2. And then now we can use any one of these points to get the equation. All right, so I know that the center normal passes through the center for sure. Well, I'm assuming that this is a point on the circumference, but they gave us that. But just have to do the calculation. So let's use a center point. Let's call a center point O for reference. So the equation becomes the normal. The normal is y minus the y value at the center that it passes through equals the gradient of the normal into x minus the x value at the center that it passes through. And so it's y minus the y value at the center is this 9 right there. The gradient is this half right there into x minus half. X minus, right, let's do better. X minus the x value at the center is 4. So this becomes, well, this becomes y equals, let's write it, half x. Half of this negative 4 is a negative 2. This negative 9 goes over, becomes a positive 9. 9 minus 2 is 7. So I'm getting a plus 7. So this is my answer right here. All right, that is my answer right there. This thing is my normal. My normal. I just put a line under it. That is all. That's my normal that I've underlined. All right, half of the negative 4 is negative 2. And then we transpose the 9. 9 minus 2 is 7. All right, that's my normal using the information that was provided. Okay, that is that. All right, next question. This question is a vectors question. It says the portion vector of the points A and B relative to an origin O are such that OA is this vector. I like to do my vector as column vector. So I'm going to write OA as a column vector. It's easier to calculate. This is 3, negative 1. 3, negative 1. And my OB is going to be this vector, 5, negative 4. 5, negative 4. Those are my two vectors that were given. Let's shift these around. Well, let's make them smaller first. Let's make everything smaller. And then we can shift this one over to here. Make some space. I want us to find the unit vector of AB. Unit vector AB. Well, AB itself is not a unit vector, right? So I have to find the unit vector of AB, a unit vector in the direction of AB. So it really should be the unit vector of AB or the unit vector in the direction of AB. So to find the unit vector in the direction of AB, you really need to find the AB first and then divide it by its modulus. Simple as that. So what is the vector AB? So the vector AB is simply OB minus OA. That is O times the last minus O times the first. And so we calculate the displacement vector quickly. So the vector AB comes, we're going to subtract the value. I'm doing this vector minus this vector. So it is 5 minus 3, which is just a 2. And it is negative 4 minus a negative 1. Let's look at it. Negative 4 minus a negative 1. Negative 4 minus a negative 1. So this minus becomes a plus, which is negative 4 plus 1, which is negative 3. So this becomes a negative 3. So that is our vector. We need a modulus of it in order to get the unit vector. So I'm going to write the modulus right here. So this tells me then that the modulus of the vector AB is the square root of the 2 squared and the 3 squared. So we get the modulus 2 squared plus 3 squared. Don't need a negative on the 3. But when you square the negative, you get a positive anyway. All right. What is that? So what is this? What is this? Let me shift this over. Everything here can be shifted over. Some space like here. All right. Now what is this one? This is 9 and 4. That's 13. 3 squared is 9. 4, that's root 13. I'm going to put this as square root of 13. Square root of 13. And therefore, the unit vector, let's put this part in purple, the answer. So the unit vector that I wanted is written AB with the hat on it. It is 1 over the modulus, which is this, root 13, over divided by the modulus, and multiplied by the vector AB, which is this, which is 2 minus 3. But I'm going to leave my answer like this because he gave me the question with ing. I'm giving back the answer with ing. So I'm going to shift this over some more. So I can write my ing. So essentially, this then becomes 2 over root 3i, 2 over root 13i. All right, so I get 2 over root 13i, and then negative 3 over root 13j. So that's minus 3 over root 13j. And that is my unit vector right here. We calculate the modulus of this, we're supposed to get 1. Let's check it. So the modulus of this vector, because the unit vector is supposed to be 1. So let's just check it. So it will be the square root of this expression squared, which basically will be 4 over 13 plus this expression squared, which basically would be 9 over 13. And voila, we get the 1. So this is absolutely correct. All right, so that was like a quick check. This one says we have to calculate the acute angle AOB given answer to 1 decimal place. So we're going to use scalar product. All right, so how it goes is that angle we're going to call it theta firstly. Let's go back for the blue. So we're going to call it angle theta. All right, and remember the angle between two vectors when they're both diverging or both converging. So angle is at O, so we're using two diverging vectors from O. And A is here, and you have OA, and let's say B is here. This is a schematic of it. And we're trying to find the angle theta between them, like that. So the theta becomes cos to the minus 1 of the scalar product, which is OA dot OB, scalar product, over the modulus product. Modulus product is the modulus of OA times the modulus of OB. That gives us the angle. All right. That's what we're calculating. So doing scalar product over the modulus product. So the theta then becomes cos to the minus 1. They really give a small amount of space for these things. What's the scalar product of these two vectors? These two. So first we multiply the 3 times the 5, we have 15. Then we multiply the negative 1 times the negative 4, we get a positive 4. over. What's the modulus of this vector? It is the square root of 3 squared plus 1 squared. Square root of 3 squared plus 1 squared times, what's the modulus of b? Modulus of b is the modulus of this one. Square root of 5 squared plus 4 squared. So we need to put the minus. 5 squared plus 4 squared. Square root of 5 squared, 5 squared plus 4 squared. And all of that is under the square root sign. I'm going to put everything in the calculator and get one answer, because I don't give a lot of space to work. All right, so let's do that. So I'm going to do cos to the minus 1. Well, right in the text, but then radians, I have to change it to degrees. So look up at the top there. You're going to see all the top at the top is in radians. So we'll change it to degrees. I've now done that. So right, I'm now putting this in the calculator. This cos to the minus 1 of a fraction. And the numerator we have 19, the 15 and the 4 is 19 over. Then this first bracket, this first expression is a square root. Square root. All right, and then this is 9. 3 squared is 9 and 1 make 10. So square root of 10 times another square root. And this is 25 and 16. Let's just write it out. 25 plus 16. That's the 5 squared is 25, the 4 squared is 16. And I'm getting my answer, 20.2 degrees. 20.2 degrees. Let's put it there. 20.2 degrees. They did say 1 decimal place. What is it? Let's change this to the schematic here to red. Change that to red. All right, that's my angle. Next part says we have to solve this equation. This is classic equation to solve. With the equation. We have the combination of sine squared and cos. Remember that the sine squared can be written as 1 minus cos squared. That's the process we're going to use. That is the same as 1 minus cos squared theta. And we are multiplying it by this 2. So that expression there, why did we do that? Because we have a cos here, and we know the sine squared can be expressed in terms of cos squared. So when I set up for the creation of a quadratic in cos. So this side is going to become 2 minus 2 cos squared theta. This is equal to 3 cos theta. Now mind you, we only want angle between 0 and 180. So that one angles only in the first 2 quadrants. All right, but let's continue first. I'm going to transpose in a way to make my square term positive. So I'm going to take everything over onto this side. So when this goes over onto the right side, it's going to become a positive 2 cos squared theta. So it becomes 2 cos squared theta. This is already over there as 3 cos theta. And then this 2 will go over and become a negative 2. And we are now equal to 0. So it's as if we would have equal 0 here, but I can instead put it out here. Don't really matter. So equals 0 here. And then there's a matter of factorizing this, which it can be factorized. These are prime n numbers, so it's easy to factorize. So I'm going to factorize it. On this, I'm going to get 2 cos theta and cos theta. From this, I'm going to get 1 and 2, but my midterm is 3. I need to put 2 with the 2 out here to make it 4 minus 1. So I'm going to put the 2 here, the 1 here, and signs are different. Give the greater product plus. Greater product with this one is 4. Make that plus, make that minus. Then this gives me cos theta equals half. This gives me cos theta equals negative 2. But cos has to be between 1 and negative 1. Right? So this is not valid because cos theta can only be between less than or equal to 1, greater than or equal to negative 1. This falls outside range. And therefore, this is not valid. Not valid. as this solution is not valid. That expression is not valid. So I'm really solving this, and I only want the second quadrant. So see, I don't want that space to work. I cannot understand it. They just don't give it that space to work. All right. So quadrant diagram for this, let me just put it over here then. Quadrant diagram for this solution here is where cos of an angle is positive. It's positive here and here. But remember, they only want angles up here between 1 and 180. So let me just make a mark. And that the only one angles up to here. All right, they don't want angle down this section. So for example, we can't give them that. So we want now the principal acute angle for a half. Let me take this out. Principal acute angle for a half is that alpha. So the alpha becomes cos to the minus 1 of the positive of this value, which is just a half. And so the alpha equals 60 degrees or pi by 3. Because the cos of pi by 3, cos of 60 degrees is a half. I think that's the answer now because I can only take angle in this quadrant. If I wanted angle in this quadrant, I would have to use, what I want degrees. They want degrees because I wanted degrees. So I'm going to put the angle in degrees, which is 60 degrees. Cos the minus 1 of a half is 60 degrees. Right. So if I were to use this quadrant, I would have used 360 degrees minus the alpha. Where the alpha is a 60 right here. But it's not there. So my answer is just the first quadrant value, which is 60 degrees. So that is it. So my theta is 60 degrees. All right, that finishes that part of this question. Let's move on, starting to feel sleepy. All right, so we have this proof to do. So here's a proof. All I need to do is make these into one fraction. It works out itself. Something to make note of before we proceed. Every time I see 1 minus sign and 1 minus cos, one minus sign and 1 plus sign, I know that it comes from cos squared x, which is 1 minus sine squared x. And the 1 minus sine squared x becomes 1 minus sine x in space times 1 plus sine x. So these two eventually is going to generate for me a cos, but I need to make this into one fraction. These two, make them into one fraction. How do I do that? How do I do that? I'm going to say the left-hand side of this expression or this relationship is equal to multiply this fraction by this denominator. All the two denominators have to be the same. So like I'm multiplying this one, numerator and denominator by 1 plus sine theta. So I multiply this by 1 plus sine x, I multiply up here also by 1 plus sine x. All right, that's what we're doing. So this one becomes, I multiply numerator and denominator, I get 1 plus sine x over this times 1 plus sine x, 1 minus sine x times 1 plus sine x. All right, that's what I'm doing. And then I have to do the same thing to this fraction. So I'm going to subtract and shift this over. Shift this all over. I want them to have the same denominator. Shift this all over here. I'm going to do the same thing to this fraction, which is to multiply numerator now by the minus. All right. So for this fraction, it's going to become just like I multiply the denominator by 1 minus sine x. I multiply the numerator also by 1 minus sine x. All right. So the two fractions are the same denominator. So this one is going to become 1 minus sine x over the product of 1 minus sine x and 1 plus sine x. All right, and then this now is, as I said, the difference of two squares. this under here becomes cos squared, as you can see. All right, I'm going to consolidate the numerator. So my left-hand side is going to become, with the numerator, is this numerator minus this numerator. So what do we have? 1 minus 1. 1 is gone. We have sine x minus a negative sine x. That becomes a plus. So it becomes 2 sine x divided by, and each of these denominator is cos squared based off this identity that I wrote initially. So my denominator becomes cos squared x. My solution has tan and cos on it. And so I'm going to split up this cos squared and write it instead as 2 sine x over this cos. I'm going to write it as cos x, cos x. And then what happens is that this sine over cos is tan. That sine over cos is tan. So the result then is that the left-hand side becomes equal to 2, that's a 2, sine over cos here is tan x over this 1 cos x that is left. That equals the right-hand side. So therefore shown. My eyes are falling asleep. I'm going to try and push through, and I'm going to try. I'm now at the end of number 3. All right, so we've got 3 more questions to go. Let's see. So I'm going to start number 4 in the next video right here. Okay, so let me get off here and do that.